In 4.4, we are going to still discuss t-tests, but now we're going to have a little bit difference. With these further t-tests, you always must start with an f-test. So t-test will compare the means of two different sets of data. So typically the question will say, are the means of two sets of measurements statistically different? So if you make two sets of measurements of the same quantity, generally the means are not the same due to random variations of the measurements. So we'll do a t-test to determine if they are statistically different between mean 1 and mean 2. So just like with the f-test, if the t calculated is bigger than the t-table, then we will reject the null hypothesis and the means are significantly different. So considered very, very significantly different. There are three different cases. Case 1 is when you compare a mean to a known value. So that's going to be your confidence interval. Which we already did in 4.3. So with these questions, you're typically given, this is the known value, here's a set of data, is it significantly different? That's pretty straightforward, and you just need the confidence interval equation. For cases 2, you have two different sets of data with many replicates, and you're comparing both sets of data. So you'll have two means, two standard deviations, two values for n, and you're going to be comparing those means. In case 3, this one's when typically you have limited amount of samples, so you might be comparing two different methods, but only one replicate. That's a big key word here. No replicates here. Sorry, there's no replicates here, but like only one sample. So it's very, very different, and this math is not typically going to be asked in the short answer part of the exams, but you still need to be comfortable in knowing when to use a case 3. Here's how a short answer problem could be asked. You're not going to be given what case they are. You have to decide which one and when to use it. A coal sample is certified to contain 3.19% weight sulfur. A new analytical method measures values 3.29, 3.22, 3.30, and 3.23 weight percent, and they give us the mean and the standard deviation. Does the answer using the new method agree with the known answer? So the true value is 3.19. We just need to do the confidence interval and say, okay, is that 3.19 in that range? And if it is, they are not significantly different. If it isn't, then they are significantly different. So what we need for the confidence interval is mean, which they gave us, 3.26. We need t-table, standard deviation, and square root of n. So we don't know what t is just yet. We know standard deviation is 0.041, and we know 1, 2, 3, 4, square root of 4. So now we need to just go to the table and find what is t. Before we do that, we have 4 data points. Degrees of freedom will have to be 3. And since nowhere in this question are they saying at what confidence interval or level, we will assume it's at the 95%. All right. Now we have to go back to the table, find degrees of freedom, and then at the 95th percentile, so 3.182. We can put it all together now. 3.26 plus or minus 3.182, 0.041 divided by the square root of 4, and I get 0.0652. So make sure these line up, and our answer is going to be 3.26 plus or minus 0.0, and then 5.2, this 5 will cause it to round up to be 0.07. So these have to line up. We need to see if the 3.19 will fit. So I'm going to subtract 0.07 from 3.26. So 3.19 all the way to 3.33. Okay. If 3.9 is in this range, then it is not significantly different. And since 3.19 is on the low end, then it's still within this range. So does the answer using the new method agree with the known answer? I would say yes. It is not significantly different. Just make sure you don't always answer these problems with just a yes or no. You have to back it up with your data. Here's a case 2A. I do provide these equations on the exam, so don't worry about having to memorize it. But we always have to start with an F-test, because if it passes the F-test, meaning that F-calc is smaller than F-table, and the standard deviations are not significantly different, then you have to do a case 2A. If the F-calc is greater than F-table, then you have to do a case 2B. So in this case, it's using the same data that we just did using the F-test. We've already done this math. We found that F-calc was smaller than F-table, so the standard deviations are not significantly different. So we're going to practice this using the same one, but just moving one more step for a t-test. But remember to always do an F-test first. Okay? Do the two means of the two methods differ? So this is definitely a t-test because it's asking about the means. I know it's a case 2A because the F-test does pass, but you definitely want to check, so let's do it again. I'll just, F-calc was, I think, 5.08. Nope, sorry, that was F-table. And then 0.47 divided by 0.28 got 2.817. And so F-calc is smaller, passes the F-test, and so that's why we need to do the t-test for case 2A. Let's continue. We've done the F-test, it passed the F-test, so now I'm going to do the t-test. So start with S pooled. And it's going to be the square root of S1. We did initially say this was the data set number 1 because the standard deviation was higher. I'll follow that trend. So it's going to be standard deviation squared, and then number of measurements minus 1 plus standard deviation of the second one squared, and then 10 minus 1 divided by N1 plus N2 divided by, or minus 2. So 10 plus 4 minus 2. Also degrees of freedom, because your t-table only has one column, it doesn't have multiple degrees of freedom. So this is only for a case 2A, will be N1 plus N2 minus 2. So S pooled was 0.338, and now I can plug that into the t-calc. And it's multiplied by square root of N1 times N2 divided by N1 plus N2. Sorry, I ran out of space, so I'm just going to move this down here. And I find my t-calc equal to 0.3, a very, very small number. All right, so we have t-calc. Now let's figure out t-table. Remember that with two different sets of data for a case 2A, degrees of freedom will be N1 plus N2 minus 2. So 4 plus 10 minus 2 equals 12. But according to this table, it's somewhere between these two, and it's going to be at the 95% confidence level. So I will, pick either of these numbers. You can definitely pick the smaller of the two or the bigger of the two. It does not really matter. So t-calc equals 0.3, t-table equals, 2.228. It doesn't matter, or 2.132. It doesn't matter because t-calc is so much smaller than the t-table. So are these means significantly different? No. Here's a practice question. You are asked to compare the means of two data sets, A and B, with the standard deviations that are not significantly different. The number of measurements in each data set is in A and in B respectively. The number of degrees of freedom is. So this is only with the case 2A. If it fails the F test, you have a very different equation for degrees of freedom. So for case 2A, it's going to be NA plus NB minus 1. Or sorry, I got that one wrong. NA plus NB minus 2. What happens if the sets of data have a failed F test? So if you still have to compare the means and the standard deviations of the two methods are significantly different, we now use a case 2B. So we will do the F calculated or the T calculated, and the degrees of freedom equation is very different than the other one. So you will be provided these equations on the exam, but you just got to make sure you're not making those simple errors. Very easy with the thickness of these equations. Most importantly, degrees of freedom are always to one decimal or one digit, so you must round whatever you get to one digit. Okay, let's practice. So Lord Rayleigh and the discovery of argon. So dry air is composed of around 1/5 oxygen and 4/5 nitrogen. Measured nitrogen with 2 experiments. So we have experiment 1 measures the mass of nitrogen after removing oxygen from air. Experiment 2, mass of nitrogen generated from chemical decomposition. Do the means of the two methods differ? And they gave us data sets, data set 1 from air, data set 2 from chemical composition, and they were nice enough to give us averages and standard deviations. This gives us so much more room. It just summarized the data. So the average mass of nitrogen from air is number with a standard deviation of number, and they gave us the other two. Before we can actually start this problem and compare the means, because it's asking, are the two masses or the means significantly different? If it said standard deviation, I would do an F test. But because it says masses, I have to use a T test. But start with an F test. If it fails the F test, goes to a case 2B. So passes. Okay, so F calc will be the square root of S1 squared. So I keep saying square root, squared. S2 squared, but S1 has to be bigger. So here's where we have to make sure we don't make a mistake. S2 is the bigger value. So I'm going to put that number on top because it has to be greater than 1. And I get a very large number. I'll round it up to 93. If you look at your F table, this 93 is going to be bigger than everything on the table. So I'll already say it now. 93 is going to be much bigger than the table, but I'll show you on the next slide what the actual number is. But just note that this one definitely fails because this number is bigger than anything on the table. So for S1, so N1 will be 8, N2 will be 7. I had to flip these two data sets because of the S1 had to be on top, being bigger. 8 and 7. All right, so if we need to figure out what F, so skipping the, I guess, finding F real quick, look at all the numbers on the table. The biggest number is 39. So even if you accidentally got the wrong F table value, you'd still be correct in knowing that it fails the F test. But let's practice 8. So degrees of freedom are going to be 7, and then 7 degrees of freedom are going to be 6. So F table is going to be 5.7. 93 is much bigger than 5.7, so it definitely fails the F test, and we have to do a case 2B. Now what? Okay, case 2B, we need to figure out the degrees of freedom. So I'll rewrite the degrees of freedom equation. It's going to be very hard. Your setup is the most important thing. Parentheses are your friend, and I highly recommend breaking this up. When I find the answer, I get 7.17, but if I round it to the nearest integer, it is 7. So our degrees of freedom are 7. If you didn't get this number, double check your math. Now, our degrees of freedom are 7. They did not tell us the confidence level, so I can say that the t-value, or t-table, is 2.36. So for the t-test for a case 2b, looks something like this, and I get 21.68, a very big number. So t-calc is much bigger than t-table. So the means are significantly different. So you can rewrite it and say, yes, the masses are significantly different. While the case 3 is not going to be math that's going to be in the short answer portion, you still need to be very comfortable knowing when to answer it, just in case it's multiple choice. If I give you a variety of different situations, can you answer what different type of case it is? So it's a paired t-test for case 3 for comparing individual differences between different methods and samples that are not replicates. So each sample is unique. So you use 2 different methods to make single measurements on several different samples. And then I recommend using Excel because the math's kind of complicated. So you have to find the difference, and you do a bunch of math based on the differences. So find the mean of the differences, find the standard deviation of the differences, number of samples, and then you can do the t-calc here versus t-table. So same setup once you have the degrees of freedom, but it's a little bit harder math.